So, just looking at different attributes of scale out, and scale out is well accepted in the industry. We kind of pioneered that left hand. EqualLogic followed, Iceland followed, even 3PAR, claimed scale out their mesh 8-node mesh architecture. And so scale out is kind of a common thing. Customers look for it. It's a feature set. Wow, yeah, I can scale out to a customer means, I can add performance capacity without bottlenecks by Lego block approach, right? But if you look at SSD, how does SSD change scale out?
So maybe we could hit the why hybrid before we get into scale out.
Okay. So the reason we did a hybrid approach is because, like Chris said earlier, customers need performance and capacity, not just one or the other. So if you're a 100% SSD player, even with dedupe, your cost of storage is still higher than dedupe on a hybrid, right? So and customers are looking for capacity and performance. A good example is you see these accounts that have like Facebook, they're a huge Fusion IO customer, and they have hundreds of Fusion IO cards and hundreds of servers, but data does become stale, at some point in time, and then you ask yourself, well, do I really want that stale data that's never being accessed sitting in my most expensive resource or not? What you really want is it to move down into a more cost-effective resource. Now, if solid state becomes as cheap as disk, fine, 100% solid state, but today that's not the case, so hybrid makes more sense. Or, a cheaper disk tier for stale data, whether it's a cloud tier or whether it's a local disk tier, whatever it might be. You want that stale data to be put into a data landfill or data archive, and it doesn't make sense for a data archive to be solid state, right? Because solid state's all about performance and low latency. So that's why we believe that the hybrid approach is the right approach. You want to add anything to that, Kelly?
No, I think that's right. We kind of talked about it earlier, that we can actually plug in any type of storage, characterize it, plug it into the system. We're not just a two types of storage hybrid. We can be a hybrid of anything. We've talked about, we even talked about violin boxes, plugging a violin PCIe box plugged into us. I know, yeah, make you shake. But there's some reasons, there's some markets that need that much storage that's high speed. So we can actually plug in anything. It was a whole design decision. We don't build the hardware. We know the hardware is going to be changing. We want to just be able to use and take advantage of any new storage mechanism it has advantages and disadvantages, play to its strengths, hide its weaknesses.
Yeah, I think the key thing with that hybrid is if you look at what's happening from a storage media standpoint, there's a proliferation going on. There's all kinds of new storage media that's coming out. If you look at solid state, right now it's more expensive than disk, but you could definitely see a world where there may be a solid state tier that will eventually be less expensive than disk. In that world, there's probably going to be multiple tiers of solid state. Some that will be designed to go really fast, some others will be designed to be really cheap. So in that world of media proliferation, I think we've taken the hybrid approach, recognizing that we're going to have to change and evolve, just like the storage media technology is going to change and evolve.
Now the market's moving extremely fast. There's SLC, MLC. MLC is 2 bits per cell. It's going to go to 3 bits per cell, 4 bits per cell. Or they're saying there's some physics limits around once you get past 3 bits per cell that need to be overcome. And then you've got the guys out there saying phase change memory is going to, make solid state obsolete, and so that'll come into the picture. So, with that in mind, our thought process was, well, we don't care. We shouldn't care. Whatever that media type is, you put the best interface to that media that makes sense. If it's a high-speed, low-latency media, you want a very fast, low-latency interconnect. If it's a very slow, media, then slower interconnect's fine. And then our QoS engine can take those attributes of all the different media types and manage them based on a policy. And so that's what we're all about, is dynamic data tiering between multiple media types to deliver a service level. And we believe eventually that's the way the cloud's going to go. You're going to have different QoS parameters for different data types, and that data just needs to flow into the right media to deliver that service level, whether it's disk, tape, phase change memory, or solid state, or RAM for that matter.
And your QoS chain is modular enough to say, okay, we've got kind of ridiculous number, 6 different tiers of memory quality or of storage quality. And you can change, like, okay, cool.
So Kelly, maybe just comment on some of the design philosophies that you've adopted.
Yeah, I think we've kind of hit on a lot of them.
Excuse me, my chair. My chair.
The whole design is around the future. It's actually part of the reason we picked NexGen as a name for us. We're actually always looking towards the next generation, looking to see what's coming, looking to what's there. We don't know exactly what's coming. We've got some good ideas. There's a list up there of some things that we have that we know that are visible. I can't tell you what's going to come 5 years from now. But our architecture and our software and our entire design is geared around it changing, it adjusting, us being able to take advantage of the system. So you asked about multiple, how many can we handle? We can handle it, and Chris even hit on it here. Memory. Memory is non-persistent unless you put battery behind it or some supercache or some form of technology. There's a value for us in that too. If someone says, hey, I don't care about data redundancy, we can plug it in memory. And if we lose it, if we power off, they said they didn't care. It's such a low tier for us. It's not what we do. It's not where we're at. But if we ever saw a customer really push us into that realm or an environment that says, hey, look, I've got it backed up on 16 other systems, just put it in memory. Sure, great, we can do that. So we're looking for the future for whatever comes out. And we know where you can. Looking Glass is not perfect, so we designed from the ground up to handle it and to be able to take advantage of new technologies. We use PCIe pretty extensively today. SAS is out there. New technology comes out that's a better, faster interconnect or has more bandwidth but might be slower, no problem. We can characterize that, plug it into the system.
Do you see you guys? Do you see your gear expanding to more than one chassis per control domain, like external storage, external SAS,
Yeah,
external PCIe?
And I can let the marketing guy take a little bit of it, but I'll take some first.
Okay.
Today we actually have JBODs, so we can scale up in capacity.
Okay.
And we can actually scale out in performance because we can plug more fusions or more solid state into the same box.
Mhm.
That's today. Down the road, we have the ability to scale out with PCIe. I've done this in the past with some of my previous experience where we can go out to a fabric of PCIe and have multiple controller domains. So if you look at our single box today, future, right?
Yeah.
If you look at our single box today, it's a 3U, 2 compute domains inside, high-speed interconnect between them. Take that outside, go to multiple 3Us, high-speed interconnect in between them, right? A lot of people would use Ethernet or 10 gig or 1 gig or whatnot. We can do this with PCIe. So we can go external with PCIe. Something else comes out that's better than PCIe. Our architecture is not tied to it. We can go to whatever interconnect, Sam Frank interconnect that becomes faster and better, and we can actually go outside the box. That's one mechanism of getting kind of outside the box and bigger, outside a single 3U. We also, on our async rep or sync rep is one of those things that actually is a next big one for us so that we can have 2 boxes, remote locations, and have redundancy amongst remote locations. PCIe between boxes doesn't scale to that. If you want one in New York and one in Boston, you're screwed. So there has need for other interconnects between boxes that's not as high speed as a PCIe would be. So down the road, we'll be able to give you all those options and take advantage of whatever technology makes the most sense for the environment that we're at.